G'day, another SideQuest here. I picked up this brand new warranty return inverter. It's a 6.7 kilowatt. No information on it, just that it doesn't work. So we'll power it up. This little guy. Alright, so there is life, that's good. Should be seeing 240 volts here on the output, but so far nothing. Not a good sign. And there we go, fault 09. Let's go check what fault 09 is. Okay, fault 9 is bus soft start failed. That typically means when it powers up for the first time, it'll slowly ramp up the power to the 380 voltage bus. And if it can't get a voltage reading, it'll shut down and give error 9. So this usually means there's a dead short across the high voltage bus. This is usually one of the AC output IGBTs have gone bad. So we'll pop the cover off, make sure everything's discharged, and start probing around. So this is what's typically inside of a MPPT inverter. There's a few different stages. This is the solar input. It basically goes straight through the inductor here, which is a boost or buck converter, and into the high voltage bus. That's about a 380 volt bus usually, maybe a bit higher. And we've got some pads here, you can see down there, that'll be positive, and down there is negative. So we can measure resistance across the bus. Maybe hard with one hand. There we go. And yep, we've got a dead short. So on this bus, it could be the output rectifier from the 48 volt to 380 volt transformer. It could be the AC output H-bridge, or it could be the MPPT converter. So I guess what we'll start doing first is we will check all of these IGBTs. When they go bad, they typically, but not always, will fail gate to source, or gate to emitter, I guess, on an RGBT. So we'll check all those, check all these, and then we'll check the low side. So this is 48 volt to 380 volt sort of power stage. So we'll check those. Typically when these go short, this will try, I guess, maintain the 380 volts, and then one or more of these FETs here will fail. So we'll go through, find out what's failed, and see what parts we have. Okay, and this IGBT here is dead short, or at least it's short from gate to all other pins. It could be the gate driver has gone short, that's entirely possible, but I think we'll chop this out of circuit, take it out, measure it out of circuit, and go from there. Also, while testing all these low side 48 volt MOSFETs, this one here is also dead short. So I'm guessing once that failed, high current, this tried to maintain the voltage, and ultimately that little guy there failed. I'm not sure if I've got spares for those. I might have. We'll take a look, but we'll start by getting this that IGBT out. Okay, we've removed the IGBT, and we've got a short from gate to collector, collector to emitter, and gate to emitter. So this is well and truly cooked. So that's good. I might try power it up now with that out of circuit. I've double checked, and the short across the high voltage cap there is gone. So I'll pop the controller board back in, the LCD, and power it up and see if we get the high voltage bus. Okay, new fault, fault 01. It's progress. And fault 01 is fan locked when inverter is off, and that is because there's no fans plugged in. So there's no RPM signal from the fan, so that's throwing an error. So I might go ahead and just fit the new IGBT and install this back into the chassis, and we'll see how it goes. And just as a quick check to see if that was the cause of the short on the bus, we'll probe the high voltage now. If we can get to it. There we go. And that is decaying, but yep, there was high voltage there on the bus. So that was the issue. and replacing that should hopefully get it back to life. I will have to double check all these MOSFETs. I'll get the infrared camera out and use that to make sure none of them are running hotter or cooler than the others. That's probably the best way to check, as they're all in parallel. But yep, I'll replace that IGBT and get back to you. And we found the culprits, these MOVs, metal oxide varistors. These are designed to suppress any high voltage spikes. It's like a surge protector, and both of them have gone completely short circuit and split open. And they are on the solar input, so I'm guessing the solar got struck by lightning. Shorted those out, which took out those, and it took out one from each side of the MOSFETs for the 48 to 380 volt supply. So with those removed, I did pop another one of these IGBTs, but luckily I got a few spares, and that was due to these being shorted. Once I found that, replaced both of those and removed those out of circuit. So we're not going to have the full 6 kilowatts available until we replace those, but they're all good. Okay, it's up and running, so I might wrap it up here. I did have to remove these two MOSFETs here. They're on the 48 volt side of the power supply, so I can't really stress test it at full load until I replace those. Now, there are no replacements available in the Western market. There are Chinese dodgy ones off AliExpress, but I'm not going to risk that, so I might just upgrade all 10 of them with some genuine parts there. These surge suppressors, they're only $1 each, so I'll replace those, and those are already replaced. So a nice simple fix. This cost me $30 and maybe $30 in parts, so yeah, not a bad little bargain there. Alright, I'll see you on the next one.